In this video, I'm going to demonstrate a type of chemical reaction that is called decomposition. Now, the decomposition reaction is one of the several types of chemical reactions. And what it is when you have something that is a compound, and through the process of the reaction, it splits apart into one or more parts. So the reaction that I'm going to demonstrate is a sodium bicarbonate deconstruction, thermal decomposition. And so we're going to begin that by adding heat. In the flask, the key here is that to begin with, it was a dry powder and room air in the flask. And immediately upon putting heat, the decomposition begins to take place. Water is one of the products that is formed in the decomposition. And you can see right away that the water is condensing on the inside of the glass. The next thing that's going to happen is when the temperature reaches a certain point, the sodium bicarbonate is going to begin to break down and release carbon dioxide. And the carbon dioxide is going to inflate the balloon. Now, obviously, another thing that's going on is that the temperature is increasing, which is causing the gas, the air, the room air, to also expand. So part of the balloon inflation is a volume temperature reaction where the temperature of the gas goes up, the volume of the gas goes up as well. But after the reaction is over, we can let everything cool back down, and the balloon will remain inflated. So we will watch this reaction through to that point. So at this point, I'm going to turn off the gas and stop adding heat to the system. Now, as the contents of the flask cool down, the contribution of the heated air will go away. So the volume of the balloon will decrease, but at the same time, the thermal decomposition is continuing and more carbon dioxide is being produced. So we will let this sit for a few minutes and see what happens. Okay, it's cooled down enough I can handle it a little bit. So I'm gonna take it off the ring stand and set it on the lab table, and that will hasten the cooling off process. Even with the flame having been off for about 3 minutes, there's still enough heat in the system to have some of the carbon dioxide continue to decompose out, and there's a good bit of water has also decomposed out of the sodium bicarbonate. The complete chemical reaction, balanced chemical reaction, is down in the notes also. It's been in the overscreen. Here it is again. So you can see what the balanced chemical equation is. You can see that water and carbon dioxide are both products. The sodium carbonate that is formed also decomposes, and that reaction looks like this. So it also decomposes and produces more carbon dioxide. So as the thing cools down, even though the air is cooling down inside the system, the balloon continues to expand because carbon dioxide is being produced. So we let this sit as long as the balloon is not going to get much smaller than this, if it gets any smaller at all. So that's it. That's the reaction of sodium bicarbonate decomposing in the presence of heat. Now, this is not a bizarre, unusual chemical reaction. In fact, this is the chemical reaction that accounts for the fluffiness of your cake batter, anything that has baking soda in it. When the temperature reaches the cooking point, the carbon dioxide is released, and that's why your cakes rise and things like that. So that's it. That's decomposition. It's a really kind of a neat example. So you can see the production of water, and you can see the inflated balloon as the production of the gas, the carbon dioxide. So there it is, and it is cooled down enough now. Obviously, I'm holding it with my fingers. So there you have it.